Hey everybody, Dr. Nelson here. This is the second video on something called difference of squares. So let's take a look at first at what you should know already. So x squared minus 4 is an example of a term that's a difference of squares because x squared, the square root of x squared is x and the square root of 4 is 2. So I know that if I want to factor it, it's going to be simply just an x and an x here, right? And then a 2 and a 2 here. And one is going to be the sum of the terms, and one is going to be the difference. So what we're going to look at today are ones that are a little more advanced. Take a look at this one down here. We have 3x squared, take away 12. If you look at it, if I said, is that a difference of squares? You would probably say no, okay? But there's a new step you need to add, all right? And it's right here. I want you to put a big star next to this, okay? You must factor out a greatest common monomial, then factor the remaining difference of squares. So what you have to do is you have to look at the 3x squared minus 12 and say, is there a greatest common factor of 3x squared minus 12? And the answer is yes, it's a 3. So what I'm going to do is I'm going to first factor out a 3. And when I do that, I'm going to now have 3 times x squared. And then when I factor out a 3 from 12, it's going to be a 4. Now look at this. This right here is a difference of squares. So now I can factor that. So this is now going to be a x plus 2 and an x minus 2. But then bring down the 3, and that's what we want. Okay? So this is adding a new step. Some of the problems we have to do is you have to first factor out a common monomial. In this case, it's 3, right? And then see what's left over. And sometimes it might be a difference of squares, and then you have to factor the difference of squares. So here we have x cubed, take away 16x. So let's see, is there a common factor? It's going to be x, right? So it's going to be x times x squared minus 16. And then x squared minus 16, that's the difference of squares. So that's going to be, let's see, an x and an x, and a plus a 4, and a minus a 4, and then bring down that x, and that's what we want. This one here, we have 3x squared y minus 27y. Well, notice the greatest common factor of 3x squared y and 27y is going to be a 3y. So I'm going to factor out a 3y, and when I do that, we're going to have a remaining, looks like an x squared minus 9, and that right there is going to be a difference of squares. So our answer is going to be 3y times x plus 3 times x minus 3. Alright, so this is like a new step. So anytime you're factoring, you want to always ask first, is there a greatest common factor or greatest common monomial that I can first factor out? And then a lot of times when you do that, you might end up with a difference of squares. So what I want you to do is I want you to pause the video and try the your turn problem now. And then when you're done, hit play. You can see how you did. All right, good luck. All right, welcome back. Let's see how you did with these problems. Okay, so the first one, we have 5x squared minus 500. Okay, and the directions say factor out the greatest common factor and then factor the remaining binomial. So to factor it out, we need to find the greatest common factor. So for 5x squared minus 500, I can definitely take out a factor of a 5. So that's going to be 5 times x squared minus 100. And now x squared minus 100 is a difference of squares. So it's going to be 5 times x plus 10 times x minus 10. And that's it. This one down here, we have x cubed minus 16x. I can factor out a common monomial of an x. So that's going to be now x times x squared minus 16. And this one, again, is going to be a difference of squares. So it's going to be an x plus 4 times an x minus 4 times x. And there it is. Here we have 2x squared minus 98. Well, I can take out a greatest common factor of a 2. So it's going to be 2 times x squared minus 49. And x squared minus 49 is another difference of squares. So it's going to be a x and an x, and a plus 7 and a minus 7, and all that is times the 2. And then finally we have x squared y squared minus 25 y squared. So again, I can factor out a common factor of a y squared. And when I do that, I have now an x squared minus 25. And x squared minus 25 is another difference of squares. So it's going to be an x plus 5 times an x minus 5, all times the y squared. And that's what we want. Alright, so the main idea here is anytime you're factoring, if it doesn't look like it's a difference of squares, well, it still could be. But first you have to factor out a common factor, and then look at the remaining factor, and sometimes it might be a difference of squares. Alright, how'd you do?